Hello out there, and welcome to our lesson on equality of sets. This lesson is going to give us a good opportunity to practice some of the set operations that we were looking at in our last couple of lessons, in particular those really complicated ones. The interesting thing about the lesson today is that although we're still looking at Venn diagrams and set operations, we aren't going to be looking at specific sets or specific elements within sets that go into areas of the Venn diagram. What we're going to be looking at is a really generalized picture, okay? Because no matter what two overlapping sets you have, or no matter what three overlapping sets you have, there are a limit to the regions of the Venn diagram where the elements could go. So we're taking away the specific sets, and we're looking at just regions of Venn diagrams for today's set operations, okay? So regardless of the elements and their placement in a Venn diagram, set operations are going to lead to specific regions in that Venn diagram. And what we're going to be trying to do is compare different sets of operations and see, does this set of operations, does it lead us to the same regions in a Venn diagram as another set of operations? And to verify the equality of certain set operations, that means to verify if these operations are going to lead us to the same places in the Venn diagram, what we want to do is locate the areas of the Venn diagrams that are being referenced by those operations. Okay, so it might sound a little complicated, but again, it's going to feel really familiar to what we've been doing. So let's look at a generalized Venn diagram for any two overlapping sets. If you have any two overlapping sets, you're going to see four regions in the Venn diagram. No matter what elements are in the sets, those elements would have to go into one of four different places. They would either go here, 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 or here. Four different regions, and let's just call this A and let's call this B. And that's a pretty generic way to label our sets, okay? So four different regions no matter what areas we're looking at. So what we're going to try to do is verify some set operations, verify if certain operations lead us to the same locations in a Venn diagram. So if we look at example 1, it says verify that the union, or the complement rather, of this union, is it going to be equal, that's a question, is it going to be equal to the intersection of these two complements? Okay, it's a lot of language, so let's try to piece this out. Let's first try to identify what regions of the Venn diagram this is going to lead us to. Okay, so that should feel pretty familiar with what we did in the last lesson. So two operations inside the parentheses first. Let's figure out what we have in that union. So if we were to unite A and B, what regions of the Venn diagram are we looking at? Well, if I was to unite A with B, if I united those two sets, no matter what elements were in there, I would be looking at the elements that are in regions 1, 2, and 3. So this is going to lead us to 1, 2, and 3. But what we need is the complement for that union. So the complement for that union means we don't actually want the elements in that union. We want what's not in that union. So we want everything else. And everything else is going to be outside, which would be 4. So this leads us to region 4. Okay, region 4. Now we're going to do the same thing with the next set of operations and try to verify whether or not in fact these are equal. Do they lead us to the same regions? And now I've highlighted, and just give me a second to catch up here. This was 1, 2, 3, and 4. Okay, so now let's look at the next set of operations. We have no parentheses here, so we're going to find this complement, we're going to find this complement, and then we'll look for the intersection for those two complements, okay? So let's, over here, actually I don't want the arrow to go there. Let's go here with the complement of A. So A includes regions 1 and 2, which means the complement is going to be regions 3 and 4. These are the regions that are not in A. Okay, so regions 3 and 4. So 3 and 4. And then we're going to find the intersection with those regions, and those regions, I'm so sorry, the intersection with those regions and those that are in the complement of B. So the complement of B. So B includes regions 2 and 3. The complement then would be 1 and 4. So 1 and 4 are over here. Okay? Now if we take the intersection of those two groups, what do we have in both of those groups? What do both groups have in common? Well, we can see 4 is on both those lists. So this set of operations leads us to 4. Okay, all leads us to region 4. So the sets of operations looked different, right? The first one said find the complement of a union, and the second said find the intersection of two different complements. But look, both sets of operations led us to region 4. These are definitely equal. Okay, so both sets of operations are equal. So we have verified that, showing that both sets of operations lead to region 4. Okay, let's try it again. So just so I don't have to keep scrolling back and forth, you have your picture there, but I'm going to draw another one. So for any two sets A and B, any two overlapping sets A and B, we are going to have 1, 2, 3, 4 regions in the Venn diagram where those elements could go. So now we're going to try to verify a couple of different things here. We're going to look for the intersection of A and B and then the complement of that intersection. So the intersection of A and B, intersection for A and B is what do A and B have in common? Right there. That's 2. So intersection for A and B is 2. Oops, let's go back to pen. Is 2. But now I want the complement of that. So what's not 2? Okay, what's not here? What's not here would be the 1 and the 3 and the 4. So we're looking at regions 1, 3, and 4. So no matter what elements were in these two sets, if we performed those operations, we would be left with the elements that are in regions 1, 3, and 4. Okay? So now let's try the second set of operations and try to determine if we get to the same regions. So this says take A and unite it with the complement of B. So what do we have in A? We have regions 1 and 2. So this is regions 1 and 2. And we're going to unite that, right? Unite that with the complement of B. So B includes 2 and 3, which means the complement would be 1 and 4. So 1 and 4. Okay, if I unite these two groups, if I united 1 and 2 with 1 and 4, what would I be left with? What regions? That would lead me to regions 1 and 2, right? 1 and 2, and I've already got 1, and now I got to tack 4 in there. So the first set of operations leads us to 1, 3, and 4. The second set of operations leads us to 1, 2, and 4. That means that these sets of operations do not lead us to the same place, so they are not equal. Okay, not equal because they don't lead us to the same regions. Pretty close, but not quite the same. Okay, let's try that again, and I'm going to use this picture again, and feel free to use the one that's above. I just don't want to keep scrolling back and forth. Okay, so for any two sets A and B, this is what our Venn diagram would look like. This is our general 4 regions. Now we're going to try to compare. Let's see, we have the complement of A united with the complement of B. Okay, so the complement of A encloses 1 and 2, complement would be 3 and 4. So 3 and 4, and then we're going to unite that with the complement of B. So B is regions 2 and 3, so the complement would be 1 and 4. 1 and 4. Now I want to unite, let's unite these two groups. If I unite, oops, took away my 4. If I unite these two groups, then we are looking at regions 1 and 3 and 4. 1 and 3 and 4. 1, 3, 4. Okay. Next set of operations says just to find the union for A and B. Or not the union. I can read, I promise. This is the intersection for A and B. And the intersection for A and B is pretty simple. That's just one operation. Intersection for A and B is here. It's region 2. That's what's in A and B at the same time, what do they have in common. So this is strictly leading us to region 2. Okay, region 2. So are these sets leading us to the same place? Absolutely not. Okay, if I unite the complements for A and B, I end up with regions 1, 3, and 4. If I find the intersection with A and B, it's region 2. Those are definitely not the same. So these are not equal. Okay. Hopefully you're getting the hang of these. Now, the next few, we're doing the same thing, but it's going to be more complicated because, if I could get my page just, there we go, page scroll, it's going to be more complicated because now we're going to be looking at 3 overlapping sets. Alright, but same process, we just got to be really careful with our work. So when we have 3 overlapping sets, we have 1, 2, 3, 4, 5, 6, 7, 8 regions that we saw we could have in that picture. So now we're going to see for any 3 sets A and B, any 3 sets, no matter what elements were involved, the elements would have to go into one of those 8 regions. Okay? So we're going to look at some operations and determine if those operations lead us to the same regions. Alright, so here, we're going to go in the parentheses first. So I'm going to leave this alone for a second and leave this alone for a second. I want to go inside the parentheses here. So what is in the union for B with C? If I unite, oh, I guess I should label. Let's call this A and B and C. Okay, if I unite B with C, B and C all together, it encompasses regions 2, 3, 4, 5, 6, and 7. So this is 2, 3, 4, 5, 6, and 7. Now what I need is the complement of that. Okay? I need the complement of that union. So the complement of that union would be everything else. Well, everything else is out here, 1 and 8. So 1 and 8 would be the regions there. Now I still have to find the intersection of those regions with A. Now what do we have going on in A? Let me get rid of some of this. Trying to be not erasing all my work. Okay, so A includes these regions here. That would be 1, 2, 4, and 5. So 1, 2, 4, and 5. Okay? So we're finally ready to do the last step, which is to find the intersection for those 2 groups. Now the intersection is what do those 2 groups have in common? What is the same on both of those lists? The only thing that's the same on both lists is 1. So these operations lead us to region 1. All of those operations lead us to region 1. Okay, now we got to try this again for the next set of operations. So the next set, again, we're going to work in the parentheses first. So I'm going to leave A alone. I'm going to leave this intersection alone. Inside of the parentheses, I'm going to go first here. So inside of the parentheses, I'm looking for an intersection of 2 things. Okay, so intersection of B's complement and C's complement. So this is a lot of, I don't think I'm going to be able to fit this over here. Inside of our parentheses, let's go with B's complement. Okay, what's the complement of B? So B includes these 4 regions, which means the complement is 1, 4, 7, and 8. 1, 4, 7, and 8. So 1, 4, 7, and 8. And then we're going to intersect that with C's complement. Okay, So C is 4, 5, 6, and 7, which means the complement is 1, 2, 3, and 8. 1, 2, 3, and 8. Oopsie, need a pen. And I am going to run out of room. That's fine. 1, 2, 3, and 8. Okay, 1, 2, 3, and 8. So now, I need the I still got to finish what's inside the parentheses there. I need the intersection for those two groups. So what is the same on both of those lists? Well, both include 1, and both include 8. So inside of the parentheses, I end up with just regions 1 and 8. Now I still have to intersect that with A. And what do we have in A? In A we have 1, 2, 4, and 5. 1, 2, 4, and 5. Okay, so now if we do our final intersection, what is the same on both of those lists? Well, both lists contain a 1. And that is it. So all of that leads me to region 1. So those operations, which look different from the first group, those operations in the first group, they lead to region 1. No matter what the sets were, no matter what elements they were, those operations would take us to the same place, which means these sets of operations are equal. Okay? I know, really complicated. Now, if you're feeling pretty good about this and you want to give it a shot, this would be a good opportunity for you to pause the video and see if you can work the next one out on your own. If not, then let's try this one together. Now again, just so I don't have to keep going back and forth, I'm going to make myself another picture here. And excuse the not so perfect shapes. Okay, so A, B, C. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so we have to take A and intersect it with the union of B and C. So let's handle the parentheses first. What do we have for the union of B with C? B and C, if I put all that together, would be 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay, so I'm going to put in 2, 3, 4, 5, 6, and 7. So I need A, which I can identify right here. A is 1, 2, 4, and 5. So 1, 2, 4, and 5. I want to intersect that with what I had here. So let me list that again. 2, 3, 4, 5, 6, and 7. So if I intersect those two groups, what is the same on both of their lists? What do those two groups have in common? Okay, so they both have a 2, and they both have a 4, and they both have a 5, and that would be it. So those operations lead us to regions 2, 4, and 5. Okay? Now let's take our next group here and see where we land. So in the next one, first it's the intersection with A and B inside the parentheses. A intersected with B. So A and B intersect here. That would be regions 2 and 5. So this is regions 2 and 5 in the parentheses there. Now I want to unite that with C. Now what regions does C make up? C makes up 4, 5, 6, and 7. So 4, 5, 6, and 7. Now my job is to unite those two groups. Now unlike the intersection, which is what they have in common, the union says put them all together. So if I unite these two, if I put all these together, I end up with regions 2, 5, 4, there's 5 again, 6 and 7. So 2, 4, 5, 6, and 7. And that is definitely more regions than what we had with the first set of operations. So since we are led to different places, we're going to say that these are not equal. Those are not equal. Okay? So I know this is going to take a little bit of practice, but you'll have the opportunity to do so in Canvas. So give it a shot. And again, if you're struggling, as always, just reach out. I'm here to help. All right. Take care.